And with that, I will go ahead and pass it over to Ben to kick off the workshop.
Yeah, thank you, Phil. Yeah, so thanks everybody for joining today. We're gonna do a beginner level ADaMS workshop using our pharmaverse packages. And I'm here with Fanny, Edoardo, and Sadchla. Fanny and I will be presenting, and Edoardo and Sadchla will be helping out in chat, answering any questions along with Phil. So today, what we want to do by the end of this workshop is to have updated some code, or at least you've seen some code updated for ADaMS, ADSL, and ADVS using pharmaverse packages, tidyverse packages, baseR, and some Pinnacle 21 like specs, emphasis on the like here. And we also want you guys to gain an understanding of how to use some of these pharmaverse packages, and also gain of understanding how to use the resources that have been built into these R packages. That's like accessing documentation, finding examples, um, like joining like the Pharmaverse Slack to ask questions. So we are going to make some assumptions in the workshop today. We are assuming you have some basic knowledge of CDISC standards, with ADaMS, like you know what an ADSL is, some STTM domains. Like when I say DS, disposition comes to mind. If you don't have that knowledge, that's okay, but that is an assumption we're making, so we're kind of going to gloss over some of those details. We do assume you have some basic background in R and some of its packages. Again, if it's your first time ever seeing R, I do think you'll gain some good knowledge here, but we are assuming you have some knowledge. Have seen R and some of its packages in your experience. Some familiarity with the RStudio IDE. You also hear it called POSIT from time to time. IDE being the interactive development environment. You'll see when we're coding that there's lots of little panes that we have to navigate around, and there's also like 4 ways to do the same thing. You'll see that brought up a few times about how to access the same information several different ways, which is a great feature, I think, of the IDE. We do make heavy use of what's called the Magritte pipe. And this is a way that we chain together our functions when we're doing our coding. So if you haven't seen that, you'll see it a lot, but we are assuming you have some familiarity with it. And we're also assuming you have maybe a dual screen setup for viewing the workshop. And if you choose to code along with us, the coding is very light. But I think that is the best way to have a dual screen setup. But if you don't, it's okay. I think if you don't even have any of this stuff, you'll still gain some great stuff in this workshop. So I just want to encourage you that we are making some assumptions with how we're working, but I think we'll try to meet you as much as we can. All right, and just to give you some kind of play-by-play, the first 10 minutes up to 10:15, we're going to do some introductions and get things set up. Then we'll move into a quick overview of some of the Pharmaverse packages and functions. At 10:30, I will start going into coding the ADSL dataset, and it's light coding. We'll take a short break. We might need to steal 5 minutes from this because we're already a little bit behind schedule. But just so you know that we are going to take a break between the ADSL and the ADVS dataset that we're going to code up. And again, depending on time, and if we have to eat in some of this last minutes about questions and resources, we'll have to bleed into this a little bit. But yeah, so overall, we really just want you guys to experience using some of these Pharmaverse packages to code an ADSL and an ADVS dataset. All right, so who's going to help you achieve the workshop objectives today? So first, Fanny Gautier, who's on camera here. Do you want to say hello, Fanny?
Hello. Yeah, so I am Fanny, working for Cytel for more than 6 years now, and I have 14 years experience in clinical and digital study reporting in oncology and neurology. I am using R on daily basis since early 2022, and because it's fun, I took the opportunity to join the Admiral development team early this year. So
Yeah,
it seems a bit complicated, but it's fun.
yeah, no, it's good. Yeah, thank you, Fanny. Yeah, so Fanny will take over after I'm done and help us code up an ADVS data set. So myself, Ben Straub, I work at GSK. Um, I also work on Admiral and some other pharmaverse packages. And I've been using R for a few years now. And it's just like Fanny, I have a lot of fun with this. It's a great community to be involved in. Then we also have Edoardo Mancini. Eduardo, are you able to come off mute and say hello?
Yeah. Yeah. Hello, everyone. This is Edoardo. I work at Roche. Been here a total of 5 years now, working in both R and SAS, but more and more R, which is great. And I'm also the Admiral business lead for the core package and for some of our extension packages as well. And I'll be hanging around in chat, trying to answer any of your questions while Ben and Fanny talk and deliver the workshop.
Cool. And then also Satchla, are you able to want to say hello to everyone? Satchla will also be in chat support.
Hello, I'm Sadchla. I love following Edoardo, Ben, and Fanny around as they're definitely my role models in R programming, but I've been doing R for quite some time and I will be in the background doing chat support.
Yeah, okay. Thanks everybody. Yeah, so definitely as Phil said, like push your, please don't come off mute. Just if you have questions, push them into chat and Eduardo and Satchel will try to answer them. And then at the end of the workshop, if there is time, we can discuss a little bit more some of those questions that came in the chat. All right, so if you'd like to code along with us, Posit has been really gracious in giving us access to a workspace for us to work in. And so I think, let's see, so if I copy the link and kind of post in chat. Sorry, I'm trying to find the chat. So
I can post it.
oh, thanks, Phil.
Yep.
Yeah, so what we want to do is we want you guys to sign up for a free Posit account, and then we can share a link for the R Pharma ADaMS workshop. And then everything there, like data, the packages we're going to use, the specs we're going to use, it's all in there and ready to go. Unfortunately for me, my work laptop doesn't work with Posit, the free account, so I have to use desktop R. But the preferred way to work is to access this free Posit account, and we will share a link. And Phil, do you mind sharing a link for the R Pharma ADaMS workshop, or Fanny, do you guys mind sharing the link so they can load in?
If you can put the link in, and then I'll put the Posit Cloud info in, and then also just mention that this is going to stay up for everybody. So this is really nice that you can use it after the workshop today. So if you'd like to continue to play with the examples and use this to learn and experiment with ADaMS and R and Admiral, you're totally welcome to do that. And then I'll share it, Ben, so you don't have to worry about this piece here. So
okay.
Yep.
Yeah, so I definitely recommend it, that this is the best way to go. Unfortunately, my IT last week decided to not allow me to use this for right now, so we're working on a fix. The quick and dirty way, if you want to get access to the materials, is you can go to the repo, which you can go in here and look at a few of the folders, exercises, metadata, and solutions to get all of the materials. So all that's available, and I will put that into the chat as well. And then, so that's the quick and dirty way. The advanced way, if you know how to clone the repo and set up everything yourself, you are more than welcome to do that. And then you can also just choose to sit back and relax. There's no obligation to code along. You can just watch us kind of mess around with things and code up ADSL and ADVS. So, if you prefer to do the Posit account and set that up, that's fantastic. Or if you want to do the quick and dirty way and just kind of grab some of the files from the repo, that's also totally fine. And if you know how to clone the repo yourself, that's fantastic. But yeah, so in the next 15 minutes, as you guys get set up and kind of figure things out in chat, I'll just kind of briefly go over some of the pharmaverse packages that we're going to use today. Oh, yeah, and I guess I should say also how is it gonna, how are we gonna code? And I put code in quotes. So Fanny and I are gonna walk you through ADSL and ADVS. We're gonna do some light discussion on each function that we're using, whether that's from Admiral, metatools, dplyr, or even BaseR. There's going to be a few times where you see us kind of fill in the blanks. That's the extent of our kind of coding today, is a kind of a fill in blank exercise with like running the code. Occasionally we'll come back and do a quick check-in where we're just going to have a poll to see if, just to check for some understanding. And the most important thing is, like, if you're not able to do the exercise or something comes up, try to diagnose yourself or post it in chat. But again, please don't come off mute, and just it's important for us to move along quickly in this 3-hour workshop. And then again, the full scripts for the repo that we shared in the chat, they're available in the solutions folder on the GitHub repo. Okay, so while you're kind of getting set up, I'm going to do a brief overview of some of the pharmaverse packages and functions that we're going to use. And then we're going to, at 10:30, we're going to dive into coding ADSL. So the 4 core pharmaverse packages we're going to use today are metacore, metatools. So this metacore and metatools are going to let us take the specs that we have, which I'll show in a few minutes, and use some of that information to help us code up our ADaM. xportr is going to be the package that allows us to write out a final XPT file. And then admiral is going to allow us to do a lot of the core ADaM derivations for ADSL and ADVS today. And I really want to mention these core tidyverse packages that we're going to use. So you'll see some dplyr usage as we code today. And you'll also see, you won't really see stringer and lubridate used that much, but under the hood, we do use a lot of this, these 2 packages in Admiral. And then xportr makes use of the Haven package to write out XPT files. And this is a great package, Haven, for like reading in SAS datasets or SPSS and some other file types. So I just wanted to mention that, we do rely heavily on these tidyverse packages. All right. And so I just wanted to mention a few of the choice functions that we're going to use today from Admiral, from metatools, metacore, and xportr. So the first one is we're going to use from Admiral, and it's going to be derive vars merged. And just so you guys know, all of these packages have a standalone website with pretty detailed documentation on how to use each function. And derive vars merge is a bit of a beast of a function, but I just want to highlight at the end here, every Admiral function and most other package functions have pretty detailed examples that are standalone that you could just copy and run to get an experience of how to use the functions. So I just wanted to highlight that's available in most pharmaverse and tidyverse packages, this detailed documentation. So we're going to make heavy use of derive vars merge today, and it's really just, I see it as like a left join, like on super steroids. It's got a lot of options. Typically, when you're building ADaM data sets, you kind of do the same thing over and over. Again, you're joining data sets. Maybe you're filtering, sorting, selecting first or last observations, and joining that onto another data set. So derive vars merge is really put together to kind of make a common kind of API for doing those kind of repeated tasks. So derive param computed, another function from Admiral. This is a great function for adding records to your data set. And you won't actually see this in ADVS, but it is a wrapper. There's several functions that are wrappers around this derive param computed that are going to add records to your data set. I think one is BSA and MAP for mean arterial pressure, I think. Next one is convert blanks to NA. So typically when you read in a SAS data set with the Haven package, it will read in blanks for missing values. And this is just a nice little helper function to kind of convert all those blanks to NA values. So this is a nice function to just prepare your data set to use a lot of the base R functions like is.na, which is very helpful in combination with the filter function from dplyr. So just, and yeah, so again, convert blanks into NA, and you can see here, there's a simple example here with how this might work. Okay, so derive vars DTM. So this is I love this function. So this one takes a DTC variable from your your SDTM data set and turns it into a DTM variable. And two things you'll see when we start coding as we go is we will make use of imputation. So we can do date and time imputation with this function, which I find is very handy. The next function that you'll see used throughout this through ADSL is derive vars duration. Does exactly what it sounds like, deriving the duration between two time points. And we'll just take a quick peek at its again. So you can see, every function has, the arguments that you can supply to it with the detailed guidance of what each argument needs to have with some guidance around it. But again, just want to stress that they're standalone examples. So if you're interested in using this function in your day-to-day work, you can see here how you can spin it up very quickly and get an experience with it. All right, and then derive vars extreme event. So I have a exploding head emoji. So I think this is a neat little function that takes information from multiple different data sets and kind of parses it down where you might need some extreme event identified in multiple different data sets. You'll see this in ADSL today, and it's definitely a longer function call. I think this is really a neat way to kind of organize grabbing lots of different information from different data sets for a patient and pulling it into an ADSL data set. So we'll briefly go over that today, but I think it's a neat little way to do something that's pretty common within data sets. But it is a bit of an advanced function, but I just wanted to highlight it at the end of ADSL. All right. And then so some other the packages that we're going to use, metatools and xportr, just wanted to highlight a couple other functions. You'll see these in action today. So for metatools, we'll use the combine soup function today. And this is a very elegant function that joins the parent and supplementary data sets. So you'll see one instance of this today in the ADSL script, but I use this function quite a lot in my day-to-day work, and I think it's a very handy function to have. Next, we have create var from codeless. So this is going to take information from the spec file that we're going to have today that I'll show you in a little bit. And it's going to allow us to create numeric variables in our data set. And there's other uses for this function, but today it's really going to be focused on just doing numeric variables. But I think it's neat that you can take information from a spec that's associated with your ADaMS data set and create ADaMS variables within it. Drop unspec vars. So this is going to be a handy function you'll see that we'll use at both in ADSL and within ADVS today, where we tend to, as we're merging on different SDTM data sets or creating intermediate variables, we just don't need them at the end of our final readout. And this great function here will take the information from the spec and identify variables that are not needed and drop them, as drop implies, from our final data set. And then finally, we'll make use of two functions from xportr and a few others, where we'll take the labels from the spec and apply that to our final data set. So any new variables that we've created or variables that we want to update the label for will be applied using xportr label. Excuse me. And then finally, we'll use xportr write to write out the XBT file. Okay. All right, so I mentioned this several times that we're going to use the specs to help drive some of our ADaMS data set creation. Again, I tried to pull a spec that's like a Pinnacle 21 like spec. But again, I don't think it's a fit for purpose. It's just a helpful guide on how we might do this. So I don't think you should use this spec that I've created in the repo and place there, for your day-to-day job. You should really just use it as a guide. But it is very similar to a Pinnacle 21 like spec. And then what's in the spec? So there's two data sets, ADVS, ADSL. It's got labels, it's got variable keys. We'll make use of both these today. We'll use functions from metatools and xportr to apply dataset labels and sort the datasets by the keys. And it also has labels, lengths, types, and we even link it to a method. And it does have code lists. So let's just take a peek at the spec. So nothing super exciting, just two data sets, ADVS and ADSL. It's got a whole bunch of variables for ADSL that we'll create today, and then a whole bunch of variables for ADVS. And things to note is that we do have code lists attached to each variable, and those code lists are in a separate tab, and we'll use metatools to grab that information and create some numeric variables today. Metatools does have a lot of other options to mess around with other parts of the spec, but we're just keeping it simple today. Okay. And there's no value level metadata within the spec. So we just really wanted to keep it simple. We do have methods that we documented in the spec. I will say that my partner or co-presenter Fanny did a fabulous job of writing up very detailed specs, and I so appreciate it. I did not do the best job in my method writing, and I apologize. But it's really just a guide, a show of what is possible. And yeah, so that brings us to ADSL. So it seems like a active chat channel. Again, if you're not able to code along, I think just watching and seeing how things work is just as acceptable as coding along. And all this stuff is on GitHub in the pharmaverse repo for you to peruse and mess around with. So since we have 2 minutes, I'm just going to go on mute for just a sec. Yeah, so we'll go ahead and get started on ADSL. And to do that, again, I can't use Posit Cloud, so I'm going to use Desktop R today. And I'm going to code ADSL. So the first thing, if you are, if you need to get access to the packages, we did write a little helper script in source exercises setup.r that checks that you have the package installed, and if it doesn't, it installs it. So if you would like, you can run this script. If you're using Posit Cloud, there is no need for you to run this script. But it just checks that you have these core 8 packages available and installs them. We use the latest packages that are available. So we don't use, if you're familiar with package versioning, we just use whatever is the latest version on CRAN. So the first thing I'm going to do before I get started is I'm going to run these 4 packages or these 8 packages real quick and just load them up using library. And the very first thing I'm going to do is I'm going to make use of spec to metacore. And what I like to do is I like to hover in between the function call and the parentheses here and hit F1. And some things to note here is when I hit F1, it pulls up the documentation in the IDE of RStudio. So previously I was showing you the package websites with the documentation. So this is the same documentation, just housed inside the IDE, which I think is a powerful way to kind of keep track of things. So everything you see on the website is also within this package documentation. And some just like R conventions, when you see things wrapped in curly brackets, that identifies the package that the function is from. So spec to metacore is from the metacore package, but we'll see other ones that don't have have names that are a little bit more obscure, and you want to know what package it comes from. So again, this is the same documentation from the website, but it lays out what is available to you for the arguments. This one doesn't have an example, but we'll see this one fire up in just a second. So that spec I was just showing you, I'm going to create a metacore object. And the one thing I'm going to change is I'm just going to type in ADSL because we just want to select the ADSL dataset from the spec. And I'm going to run this. All right. And I did suppress the warnings. I told it to be quiet. It does, because, again, our Pinnacle 21 spec it's just a guide. So there are some discrepancy in it. And Metacore will actually pull out some issues, but I just told it to be quiet for right now. It does create something called an R6 object. That's definitely for an advanced topic, but it's just an object that we've created that we can do different things to, which we'll make use of. Next, so we've read in our spec into our environment, and we'll start using that later on. The next thing we're going to do is we're going to load some helpers. So we call them ADaMS little helpers, and I'll show you inside exercises. So these are just little format helpers. They just are going to format some of our variables later on that we're going to use. But I like to keep this at the top of the script and load those in. And we're going to use the source function. So this is from baseR. So again, I'm going to hover the cursor in between source and the parentheses and hit F1. And you can see here, this is from baseR. I'm not going to scroll down because you can already see that there's quite a lot of documentation associated with source. But we're just going to execute this file, and it's going to load in what we need. And you can see here, all of these functions are available now too in our environment. Okay, so next we're going to make use of some play data from a package called pharmaverse STTM. And here we're going to make use of DM, DS, EX, exposure, AE for adverse events, VS for vital signs, and SUP-DM. And we're just going to call them in. Maybe this would be like a read SAS with like a location to where your SAS data set is. So that's why we kind of have this convention right here. So we're going to run this code. And you can see here it loaded into our environment. Again, we're making kind of some quick assumptions that you guys have some CDIS background and you're familiar with these data sets. But just take a little quick peek at the DM data set. So we got 306 observations and 25 variables. I don't want to scroll over too much, but those are all our pretty typical variables you would see in a DM data set. All right, and then these are technically already our objects, so we don't really need to run convert blanks to NA because they're not SAS data set. But I just left this in here just as a helpful reminder that if you are reading in SAS data sets, something to be careful of is converting the blanks to NAs. This allows you to use some of the baseR functions like is.NA really easily. So we're just going to run this and pretend it's like SAS data sets. But nothing changed with our STTM data sets. All right, so next we are going to make use of combined soup. And to remember where that function came from, if I hover in between and hit F1, it comes from the metatools package. And very simple, simple function to use, and it just combines the domain data set with the supplemental. So we're just going to combine DM and subDM in one line of code. And you can see now that DM, when it's combined with subDM, has an additional 7 variables appended to it. And we'll just take a quick peek at that. Pardon for the scrolling. So you can see here that this, we added on these additional variables to this data set. And this came from subDM. All right. So we'll make use of this in just a few minutes. So next, and let me just make sure I have this on the right screen. So next, we're going to make use of the derive vars DTM function. And this is going to allow us to take a DTC variable and convert it into a DTM variable. And just to, again, highlight, pull up the function documentation, and you can see what it does. The many different arguments available. Well, we are only going to use a few today. But again, the argument descriptions are all available down here about what they do. And again, there's examples at the bottom of the documentation. So what we want to make sure that we do is that I did have a few fill in the blanks here. We are going to make use of the time imputation. And this is just a exercise and just having a good time. So the DTC variable doesn't actually have any time associated with it, and we're just going to impute the last hour and the last minute of the day to this variable that we're going to create. And the variable prefix is going to be EXEST and EXEN. And we're going to tell it to make a, when we kind of invoke these imputations, it's also going to make a handy little flag for us, like a imputation flag variable for us. So let's run all this code. So we're chaining together the two functions to make two separate variables, and we'll also get two flagging variables. And we'll pull that up here, and I'm going to scroll all the way over to the side. And you can see here, the EX data set had 4 variables appended to it. Again, it's just a silly exercise, but we just imputed time to the last hour, last minute, last second of the day here, and it also made us some imputation flags. All right. So now we're going to come to derive vars merged. First thing to note is before we do derive vars merge, we are going to use the mutate function, which is from dplyr. Basically just going to rename arm and actual arm to treatment 01 planned and treatment 01 actual. Again, very simple call here, but derive vars merge is a bit more complicated. So so for beginner level, just the things to pay attention to here is we're going to merge on to DM subDM some of the information from EXEXT. And when we do that, we're going to create new variables. So we're going to use the argument new vars. We're going to use this filtering condition. And this, I don't want to go into what each part of the filtering condition is, but we want to pick out, the first observation that's in EX that is viable candidate to be our treatment start date time. So when we identify that observation, we're going to rename it to treatment start date time. And we also want to bring along its flag. So we'll have a treatment start date flag as well. And just for the mode, so this is going to be the first, and we'll pull up the documentation for that. So this is something, if you're coming from SAS programming, very interested in first and last observations. So this little piece right here allows us to pull out the first or last observation when we're doing this merge. Okay, so we will run this code and we'll get a new data set called ADSL01. And we're going to take a quick peek at it. We're going to use this line of code here called, we're just going to use the view function, and it's going to pull out anything with TRT and its subject ID. And we can see here that the treatment start date time was pulled out here and appended to our data set. And we also pulled along the flag. All right, next we're going to move on to treatment end date time. Very similar call for derived vars merged. Going to create new variables, but this time it's going to be treatment end date time. Going to use a very similar filtering to pull out the observations that we're going to need. But instead of saying first, we're going to use last. And we'll pull out this information here. Oh. Everybody mind going on mute? And then just to make sure that we got those treatment end date time variables added on, we'll take another quick view at it. And before I do that, I'm going to just clean up my space a little bit because it can get a little claustrophobic in your IDE. So here I've managed to get my treatment start date time, treatment end date time, and some flags that I made up, and we rewrote or just renamed arm and actual arm. Okay. So now we're going to have our first check-in. So if you can, I'm hoping everyone's following along as best they can. I just wanted to ask a quick question to everybody. And this would be something you just put into the poll, or sorry, not the poll, into the chat. What you think the answer is. So which admiral function, we just used it, can be used to turn a DTC variable into a DTM variable? Derive vars DTC, derive vars treatment duration D, derive vars DTM, or derive vars EXSTDC. So which of these functions did we just use to help us make a DTM variable? So please take a second, just throw an answer in the chat. Yeah. Derive vars DTM. Yeah, so I love this function. I think it's really a very useful function to use in ADaMS programming. Okay, so next thing we're going to use, we're going to create our treatment start date and treatment end date variables. We sort of cheated and imputed times onto our variables, but we're going to use the function derive vars DTM to DT to pull out just the date information from these two variables. So here I'm going to run and create ADSL 03. And just to verify that we were able to create the treatment start date and treatment end date, we'll pull up that information. And you can see here that just with a simple call to treatment, or I can't remember the name of the function, just a simple call to derive vars DTM to DT, we're able to quickly make treatment start date and treatment end date variables. Okay, and this function here too is very compact. So I just pulled up the documentation format from it. Remember curly brackets at the top here, members, that's the package that it's from. So this is from Admiral. And you can see here, only 2 arguments to supply. And we really just use source vars. And it runs over and helps us parse out the dates from the datetime variables. All right, so next thing we want to do is we just want to get treatment start time. And this is a simple, fill in the blank here. Nothing too nothing going on too much here, but we're just going to put in treatment start date time into the function. Again, very similar to derive to the function above, derive vars DTM to TM. So it's just going to pull out the time information. And we're going to run this code and clean up our workspace a bit and take a peek at all of the variables that start with TRT. And again, we did cheat and we just imputed time, so everything's going to be all going to be the same, but you can see here it extracted that information and made us a new variable. All right. So now we're going to move on to getting treatment duration in days. So this is a kind of you'll see treatment var TRT DURD. So that's going to get us treatment duration. And then there is another function, derive vars duration, that has a lot more flexibility to it. So this is just going to create this treatment DURD variable right now. And to do that, I'm just going to fill in the blank with the start date, treatment start date, and then treatment end date. Run this line of code. And it successfully ran. And now we're going to take a quick peek to make sure that we were given the, treatment duration. And this is in days. And you can scroll down and see what was filled in. And let's pull up that function documentation. Remember, I'm hitting F1. And again, you'll see derive vars duration in a few minutes. Again, there's only 3 arguments for this function, and it's really just to create this one variable for us. All right, so now we've added a lot of treatment start dates, start date times, treatment duration. Now we're going to pull information from the disposition data set, so DS, and add on some screen failure, end of study, and a couple other interesting variables we thought we should showcase. And in the next few sections, we're going to make heavy use of derive vars merge. And while that function looks complicated, it's going to be pretty simple calls that we're going to make throughout the next 30 lines of code. So the first thing we're going to do is we're just going to use derive vars dt again, and we're just going to make just to make it a simple dt variable. And we want to first identify, where patients that we're going to put into ADSL, when their screen failure date was, and we're going to pull that out of the DS dataset. And for right now, we're only going to use 4 arguments: dataset add, by vars, new vars, and filter add. So again, we're going to join this information onto our current intermediate ADSL dataset. And the part to fill in the blank, if you're trying to code along a little bit, is we're just going to create a new variable called screen failure date. And we're going to pull it from DSS TDT, so that variable that we created with derive vars dt. And the one thing to notice here is that we're going to pull that information out for anything that meets this condition, disposition event, and screen failure. So let's call that function. And we are going to take a quick peek at that one. All right, I'm just going to clean up my workspace a little bit. So you can see here that we have pulled from the DS dataset and pulled this information in the screen failure date and appended it onto our intermediate dataset, ADSL dataset. So you can see here, and I just clicked, organizing, sorting the dataset so all the screen failure dates come up. All right. So next we're going to do end of study date. And again, just to help you follow along and hopefully to keep your interest, we're going to create a new variable called EOS DT, and we're going to pull out that date from DSS TDT. And this is going to have a slightly different filter condition. So still a disposition event, but nothing, we don't want it to be equal to screen failure. Run that code. And again, take another peek at it just to verify that we got an end of study date. So you can see here that we've now added on our screen failure date to our ADSL, and then our end of study date to our ADSL. All right, and now this example is a little contrived because the study already ended a long time ago. But we're going to pull out, we want to create an end of study status variable. And we're going to make use of the format ESSTTT. And you might be like, oh, what package is that from? So that's actually not from a package. That's from the ADaMS little helpers. So we're going to use this function that we sourced earlier, and we're going to throw it into this merge call, and it's going to format, it would format, or it does format the information from DSD code. A simple disposition event is going to be used as a filter. And if any missing values are pulled out, we're going to set them to ongoing. Unfortunately, the study's over, so there's no ongoing, but I think it was nice. It's nice to see that this is an option with derived vars merged. So we're going to run this code, and we'll take another peek. So again, sorry for the repetitive nature of how we work through things, but this is the best way we thought of to present this material. But you can see here that our end of study status was appended to our data set. So we just have completed or discontinued. But it is an option that if it was missing, you could set it to ongoing using the missing values argument available in derived vars merged. All right. So one of the last pieces, well, we got a couple more that we're going to pull from disposition. We're going to go ahead and get a last retrieval date. And we're going to call this this variable, we're just going to call it frvdt. And just like all the other, slightly change the filter condition to dscat equals other event and dsdcode to final retrieval visit. So we're going to merge this onto our intermediate ADSL dataset based on this condition, and we're going to call it, when it picks out that information, any of that date dt variable information is going to be changed to this new variable. And we'll take a quick look at that. And where, oh, okay, yeah. So you can see here this information here was dropped in to the F. It wasn't at the end of the data set. That's why I got confused. But FRVT was added in right here to this data set. Okay, and then for the grand finale, before we do another quick poll, again, heavy use of derived vars merged, left join on super steroids. We're going to just filter on from DS dataset when DSD code equals randomized, and that's going to be when we set the randomization date for the patient. We're going to run this code. And again, just to verify that everything is as it should be, we have the patient's randomization date of when they first received their dose, or hopefully first received their dose. All right, so just to mix things up a little bit and keep it super exciting, we're gonna go do another quick check-in. So you saw how I could use F1. I just wanted for you guys to take a second to see how many arguments does the derived vars merge have. So you can look on the Admiral website for this, or you could hit F1 if you're coding along and bring up the documentation. There's also a trick where you could type in the console question mark and the function name, and that pulls up the documentation. So how many arguments does it have? 15 arguments, 4 arguments, 1 argument, or 10 arguments? So we've only used maybe about 5 of its arguments. So derived vars merge does have a lot other more advanced capabilities that are built in. But like we've only used, I guess, 4 or 5 arguments today. So just give that a couple seconds. Yeah, so thanks everybody for participating. It feels good. Yeah, so 15 arguments. Yeah, it's nice seeing the chat fill up with 15. Um, so we'll keep moving on with the demo. So next, we're going to use some of the small amount of information that we have on the death of a few patients in this data set. We're going to use derived vars DT again. And remember that is from, I'm hitting F1, that is from the Admiral package. And we're just going to change that DTC variable into a DT variable with a new prefix. I mean, it's the same kind of prefix, but you can change this if you desire, like if you need to create an intermediate DT variable for some reason. And we're just going to just highlight that this is some options to do some imputation if needed. These are actually complete dates, so this isn't very exciting, but we're just going to go through the motions. But we're going to use this if the DTC variable was a little bit more if there was some missing values with the death, you could do some imputation with that. But we're going to calculate the relative day of death now using derived vars duration. So remember we did treatment duration, which we had a dedicated function for, but derived vars duration has a lot more flexibility for us and arguments. We are only going to use 3. Very similar feel to treatment duration function, but I do want to highlight that this has a lot more flexibility for us. Run this line of code, and we'll take a look at the relative day of death. So only a few patients passed away, but we can see here that we have a death date and a relative day of death calculated for us. And remember, you can mess around with these different arguments for the function if you need some more nuance available to you. All right. So next, we're going to continue to use derived vars duration. And here we are going to create a elapsed days from last dose to death. And we are going to make use of an additional argument called add1. So this, and I just want to point out, so this is default to true. So when you see our documentation and it has the argument already filled out, you'll notice previously we didn't specify this in the last call to derive the last call to derive vars duration. So it actually just defaults to true. So here we're saying don't do that. So it's not going to add 1 here. So it's just to highlight why we're doing that and why we need to call that out. And I won't show this additional variable that we've added on to, but I did want to just highlight that, the argument is default to true and we changed it to false. Okay. So I think this might be almost our last. Oh no, we still got a few more Admiral steps to go to. So I won't dive too deep into this function, but you do notice one thing to note here is that this function call derive vars extreme event. So this is the one that had the head exploding earlier. So things to note here is that this is a function that's going to pull out some extreme information from two different data sets, and it's going to go in based on some conditions and pull out that information and allow us to rename some variables to death cause and death domain. So let's pull up that function. So adds the worst or best observation for each by group as new variables. So I think this is a very handy function. I think doing this with just like open dplyr or baseR code can get pretty messy. And I think a lot of Admiral purpose is to kind of standardize how the code is. So anybody could pick up the code and kind of know what's going on. Whereas like when I pick up someone else's SAS code that's not using standard macros, or someone's R code that's just using baseR, it's always kind of hard to kind of know what they were thinking and kind of trying to pick out their reasoning and seeing how they worked. So Admiral, I think, is just trying to standardize how the typical things that we do where we're pulling out lots of information from different data sets. So here we just want to pull out information from the AE data set and the DS data set and add it into the death cause and the death domain. So again, just coming over the documentation, there is some good examples down here at the bottom too that you can run as standalone examples to pull information out from. So I'll run this big chunk of code, and then it's important for us to take a quick peek at it. All right, so you might be like, oh, there's no death cause or death domain. So remember, there's only 3 observations in this data set, and we pull it up here, and we can see that information from the AE domains or the AE data set was pulled out, and it pulls out, why that person, the cause of death that was identified. So you could stack more information in here. You could add more data sets in the list of available data sets to pull information from, but we kept it simple. Okay. So next we're going to move to a third check-in. So a third simple poll. And this goes in, this will segue into our next part of creating the ADSL data set. So in the beginning of my script, I pulled information in from ADaMS littlehelpers.r. So I would like you guys to pick out which function did I use. Did I use loadall, install.functions, source, or call R? So which function did I use to source my little helper functions that aren't associated with any packages? And I'm just going to go on mute for just a second and take a sip of water. Okay, I'm back. So what do we pick? A, B, C, or D? Yeah, source. So source is a great function. It's a way to kind of pull in scripts into your code. But if you want to, and it's good to share that with your coworkers. But always recommend to start thinking about, could you make it into a package if you're using the same code over and over again. But source is a super helpful function from baseR. So sorry if I just shouted. So we're going to use those format functions available in ADaMS Little's helpers to format the race, age, country, and death domain, death cause. And we're going to create 4 new variables. And we're going to make use of mutate, which if I highlight mutate or type in between mutate and the parentheses, I get that it's from dplyr. So just a simple mutate call, and we're going to format some of our, we're going to create 4 new variables, and we're going to take a peek at them. So, not super excited. We just classified it as white or non-white for race group. The age groups, I think, only have 2 categories. Region is just NA. but we kept it simple. And death group is just an adverse event. So, but it's just an option to show you guys that you can, use these little helper functions to create additional variables. All right, clean up my workspace. Using additional dplyr functions, mutate and rename, we're just going to create randomization flags and rename to population flags. Okay, so we're coming to the end of ADSL. So now we read in that metacore, that spec a long time ago, about 30 minutes ago. We read that in. We haven't really made use of it yet. So now we're going to make use of it heavily in the next few lines of code. So for now, we're just going to create numeric variables. And if you're following along trying to code and you picked up the one with the blanks in it, do note that at lines 274, 275, you just want to add in age group 1N and race N. And the out var argument. And remember to pull up where this function is from. It's from the metatools package. And the spec that we read in earlier with metacore, which we called metacore, which I know is a little confusing, we're going to take the input variables that we have available currently in our ADSL. We're going to take that spec information and we're going to create new variables, new numeric variables, age group 1N, race group 1N, and so forth. We'll run all this code and we will take a peek. And so very quickly, we took information from the spec, the code list that we made that are associated with these variables. metatools knew enough to pull that in, and based on the stuff that we have currently in our ADSL, created our numeric variables up here. Okay. All right, so next, we're going to use several functions all chained together, some from metatools and some from xportr, and we'll be done. We'll have created an ADSL XPT file. So the first one is going to be the drop unspecified variables function. And let's see, just for some comparison. So we're at ADSL 17. That's our step. And can I get, so ADSL 17 has about 64 variables in it right now. And I believe our spec maybe has 40 some odd variables in it, but let's just drop all the ones that we don't need. So I'm just going notice here, if you're coding along, I'm just highlighting just these two lines here, not grabbing this extra pipe. And I'm just going to run this code real quick and create ADSL. Yeah, so we dropped from 64 variables to 48 variables, and these are the variables that are only specified in our spec. And you'll notice here, the function gave us a message, and this is important. This has saved me a few times. It's dropped these variables here from our data set. So just a nice sanity check that these things have been removed from our data set. Next, just to make sure that the variables that we have in our spec are in our data set, or if they're not in our data set and they're in our spec, it kind of gives us a quick alert. We'll use check variables. Again, notice how I'm not highlighting this pipe right here. I'm just running this line of code. And it's saying that there's no variables that are in our spec that are missing from our data set. So that's super good news. And there's no extra variables, which there shouldn't be because we already ran drop unspec vars. But just so you note that there is like a bit of another sanity check here. All right, so then next we're going to do order columns. And this is a nice little helper function to kind of take, we've been throwing on new variables into our data set. Some they're not in a good order that are outlined in our spec. So that metatools now will take that information and order our columns based on our spec. So we'll run that. And now, just so you guys can see, We have our variables in order here, but sadly, there's no labels. Well, some have labels, but some new variables that we created do not have labels added on. And to do that, we're going to make use of exporter label, but we also are going to take information from the spec around types. So we're going to kind of push out, if we didn't make any factor variables, but if we had, it would take away that factor variable, which is, if you are familiar with R, it's just another type, data type in R. But it will convert those to character, and it actually will add links too. So links that we specified in our spec will also be added on. So let's run that and get a new view of our ADSL dataset. So here we have all, if you remember just a second ago, there were several labels missing, and now we have all the labels added onto our dataset. Okay, and then we don't really have anything with formats in our spec, but we do have a dataset label, and we'll want to add that in. And what happened? So let's see ADSL format. And then we seem to have a problem with df label. So maybe that needs a domain specified. Okay, yeah, so sometimes the functions, and that's not the best message. So we'll have to work on that, why that failed over. But the function, this df label that's from the exporter package, looks like it needs a domain specified. So some functions don't need this domain specified, some do. Definitely something for us to work on in exporter, but I was able to quickly kind of figure that out. But just make sure, sorry about that, to see that error pop up, and it's not a very helpful error. But always good when you have an error that comes up, first thing you do, I highly recommend it, is just to go to the function documentation and see what is needed, and see if there's any examples down here that can kind of lead you in the right direction. All right, and then finally, we're just going to make an XPT file using exporter write. And I just wanted to highlight this message here. I kept it here, but exporter write, when it was running through things, noticed that some of the widths weren't set correctly, and it actually reset the lengths available. So in the spec, we had specified 6, but it actually thought 12 was needed. So you can disable these checks in exporter write. There's a function called, or there's an argument called strict checks, and you can set it to go silent. But if you set it to error out, it will fall over. All right, and this wrote out the XPT file to the datasets folder that is available here. And yeah, so at 11:13 today, we created an ADSL XPT file in R using several packages. And let's just quickly go over a review. So something I love about the RStudio environment is that you can make an outline using these little dashes in your comments. So this is like everything we did today kind of outlined, and well, it's outlined with comments. So you can see here that we worked through loading in our specs and our data sets. We did all of our treatment start date time, treatment duration. We worked through all of our disposition add-on variables like screen failure, end of study status, randomization date. We kind of used information around the death of several patients to add that information on into ADSL. We used some of our helper functions, ADaMS little helpers, to add on some additional variables that we custom made. We went through and added on, our numeric variables using create var from code lists. And we did our final preparation of dropping all of our unused variables, kind of ordering things correctly so it, the data set looks really nice to look at and makes sense. And we added on labels and wrote out an XPT file. So I highly recommend this little outline ability in your code. And I think along the way, I missed a check-in. So let's do that because we have a couple minutes. So this would be our last check-in for ADSL. So the check-in right now is how many packages did I load using library to create ADSL today? So did we load 15 packages, 4, 8, or 10? So that's just at the top of the script. So if you can throw that into chat. So how many do we create or how many packages do we use? Yeah, we used eight packages today. So 4 from Pharmaverse, and then the other 4 are from the tidyverse. There are, if you don't know how packages work, if you're new to the world of packages, packages do have dependencies on other packages. So it can get a little complicated, but trying to keep it, I always think it's a good practice to keep them as few packages as you can make use of in your scripts, because package versioning can cause you some headaches down the road. But there's ways to work around that or to future-proof yourself against that, like using RENV package to kind of lock things down. So that brings us to the end of ADSL. I appreciate everyone tuning in and listening. I think we should only take a 5-minute break. I think 10 minutes is a little too long. But this is a good opportunity for everyone to stretch their legs, get a cup of coffee, run to the restroom. So I think let's say at 11:25, we can come back and get started with ADVS. Let's make an update to the new slide. The slides that we've been using for this presentation are made with something called Quarto, which I find really fun to use. So I'll just make a quick update. So we're going to start. So we'll start ADVS and at 11:25, and let's see if we can get this to render. And we'll just have a quick little mini demo of ADVS running on my computer. Or sorry, not ADVS, the Quarto documentation. But while that's getting set up, these slides are linked on the repo here. And if you're curious, I'm always curious about people's slides and how people make things and how they present stuff, but it's just in the slides folder, there's a workshop.qmd file here that's available. I think Quarto is great. It's very easy to use. I think the revealed JS part of it is really fun to use. So where am I? Yeah, so here we go. We made a local version of our slide deck. And we'll get started with ADVS at 11:25. And Fanny will take over, and it's going to be a lot of fun. Folks to come back, there was a question in the Q&A about you don't see the combined soup in the ADSL.R template. Oh yeah, that's so we added this in for the workshop because I thought it was important to show metatools. In the templates for ADaMS, just for folks who are still here while we're waiting to get started with ADVS. So in Admiral, we do have a lot of template data sets, ADSL being one of them, available for people to make use of, and it has a lot of code. But we actually don't do any metadata with that because we just wanted to keep it separate from the package. So this ADSL that we have available that we just showcased today is unique to the pharmaverse. But we do have something similar on the example website, which we'll show at the end of the workshop that's related. So yeah, so with Admiral, we don't really mess around with a lot of other packages, or we try to minimize using other packages as much as possible in the templates. And so it is 11:25, and Fanny will be taking over, and I will stop talking. Thanks, Fanny.
Thanks, Ben, for the presentation. Okay, so from now, we'll see how to create a BDS finding ADaMS with the example of vital signs. For those who just joined or who were not able to join the first part, the first thing is to load the packages with the library calls. And we will read into the specs that we have prepared to apply at the end all the labels and formats, etc. And we also have a few functions and lookup tables that we have created in ADaMS Little Helpers program. So we need to source it. And finally, we need to get our data to program. So we need the vital sign SDTM and ADSL that we have previously created with Ben. If you did not get the chance to produce it, no panic. It's saved in the datasets folder as an XPT file. So you can read it simply with the Haven package. And as mentioned by Ben, it's better when you get some SAS dataset to convert all the blanks to NA value. So we'll assume that here it also comes from SAS. And now that it's set up, we can start on the programming. So to derive some variables for ADVS, we need to get some specific ADSL variables. All other ADSL variables will be merged at the end of this dataset development. So for now, we select only the treatment start date, treatment end date, the actual treatment, and the planned treatment. And these two first variable, treatment start date, at least will be used to derive the relative analysis day. So before computing the analysis date and the relative analysis day, we need to merge these variables to our source data using the derive vars merge function. So Ben already presented how it works. So we just call our input data set, and the variables that we want to merge are set in the new vars argument. So we have placed them in ADSL underscore vars. And we want to merge them by the study identifier and the subject identifier. So once it is merged, we have the possibility to derive the analysis date using the derive vars dt function. We want to call it ADT, so we set the prefix as to A, and the character date that we will use is the date time of measurement, which is VS-DTC. In our VS data example, we don't have any partial dates. So we leave the highest imputation argument to no, and the flag imputation to auto. So those arguments, if you look at the helper of the function, are by default set to no and to auto. So it's not necessary to add them here since we don't want to impute anything. So if you remove, for example, that part of code, it will work the same. Since ADT is now created, we can derive the relative day. So comparing the analysis date to the treatment start date. So for this, we say that our source variable, the one we want to compare, we want to compare it with reference start date, which is our treatment start date that we previously merged in the first step. So running it. You can see that all our variables from ADSL have been merged. We will have treatment start date, treatment end date, the actual treatment and the planned treatment. And also that our analysis date has been created as per the date time of measurements. And at the end of our data frame has been also added the relative day. So we now have 29,643 observations and 30 variables. So we have the same number of observations as in VS, plus our 6 variables added. In the next step, we will assign the parameter level values such as param-CD. We will here create only param-CD. Param and param-M will be added only at the end of the development, once we will have all parameters and records created. So for this, we will use the derive varth merge lookup function, because we have created for you a lookup table, which we sourced in ADaMS Little Helper, where we have our VS test CDs as a reference, which will be used for the merge, creating our param CD variable and later on param and param-N. So derive varth merge lookup works similarly to a derive varth merge function. So we set in our input data set argument that the lookup table that we want. So it's param lookup. And we want here to create only param CD. So in new varth argument, we set our variables that we want to create. And we merge by the VS test CD variable. Yeah, so we also have the argument print underscore not mapped, which is equal to true, and that's the default value. I advise you to keep it to true. In fact, it will give you a message if something is not properly mapped. Then we want to compute our eval and analysis value unit. So it's a simple assignment from the numeric results in standard unit. And same for the analysis value unit, where it comes from the standard units variable. So if you run it and go to see ADVS1, you can see that we still have the same number of observations as the previous step, but we have 3 variables added. So we'll have our param CD added, eval, and evalue. So having defined that, we can now add some records and new parameters. So we'll create in the same step param CD and eval. So we will take the example of deriving the mean arterial pressure. So for this, we can use the wrapper function derive underscore param underscore map, which is so the wrapper function of the more generic function derive param computed function. So I will just hide the outline. So you can see that we have several arguments. The byvarth argument is used as a grouping. So each variable defined in the byvarth will be used to create a new record as per those variables. and only the variable specified in that argument will be populated in our newly created records. As well as in the set values too, the parameters, the variables which are created here will be populated. We also have the argument get unit expression. So this argument is providing the unit of the parameter, and the result is used to check the units of the input parameters. Our input parameters here are the systolic blood pressure and the diastolic blood pressure. So again, these are the default values. So we don't have to repeat them. It was just to show you how it works exactly. But we set the parameter code in those arguments. We don't use the Hertz rate to compute our mean arterial pressure, so we leave it to null as well. You can filter as well on some values when you don't want to compute them. So for example, here we don't want to compute any mean arterial pressure when the completion status is equal to not done. So we filter on completion status not equal to not done or is missing. So currently you can see that we still have 29,643 observations. And if you run it, it will increase with the addition of our mean arterial pressure parameters. So if you want to filter for it, we created the map parameter. So you can see that we will have our records added with the values computed and the units kept as well from the byverse argument. And all variables which were not defined in the byverse arguments are not populated. Only the ones defined, specified in byverse are populated. So it's time for a little quiz. So have a look to the Admiral Discovery webpage. I don't know if you have the link. I can give it to you in the chat. If not, if I find the chat.
I can put it in there, Fanny, if you haven't.
Okay.
Let me go. So actually, do you want to show the website on the
Yes.
So this is an awesome, simple website for ADaMS programming. But yeah.
Or you can search for here for functions or variables or parameters that you want to derive. It's an easy search, and then it will give you which functions and which function you can use, and then it will redirect you to the web page as well if you need some more help. So the first question is to have a look at this webpage and let me know in the chat which admiral function could be used to derive the BMI parameter at any point. So would it be A, compute BMI, or B, derive param BMI, or C, derive param growth age function? And I can see in the chat that it's the wrapper function derive param BMI. So we can also see, because the derived param BMI works similarly as derived param MAP. We will use here the generic functions derived param computed. But B is the correct answer. So here in derived param computed, if you look at it, it looks in the same way as we have already seen for the wrapper function. We have the byverse argument, which will group your records and which will populate the variables defined in this argument. To derive the body mass index, we need the parameters weight and height. So these two arguments have to be populated. The two parameters have to be provided to properly compute the body mass index. So the difference between parameters and constant parameters is that for constant parameters, we can provide some parameters which are measured only once. And then it's merged back to our data and other weight parameter in that case, using the constant by var argument. So it will be merged by patient. So it helps to have, when it's measured only once, then you can compare at every visit, because we are doing it by visit. It's comparing, it's adding your height for each patient by visit. Because it's a generic function, we need to set the formulas that we want to use for to compute the body mass index. So we set our eval values, which will be equal to the eval from the param CD, which are equal to weight, divided by our eval values, where param CD is equal to height, divided by 100 and squared. We want to populate in our newly created record the param CD variable, so it's equal to BMI, and add as well our unit, which is kilogram per square meters. We could also add param to our label body mass index, but as said previously, we will add those variables only at the end of the ADVS development. So if you run it again, and look at ADVS 1, we now have again further records. So we have in total now 39,898 observations and still our 33 variables. If you want to have a quick look, we just created BMI parameter, so it's well added with our values, our units, and as before, the variables which were not set in the by vars arguments are not populated. The second quiz is to look at the same web page, Admiral Discovery, and let me know in the chat which Admiral wrapper function could be used to derive the BSA parameter at any time point. Oops, I've been a bit quick. So is it derive param BSA or compute BSA? Yeah, and it's correct in the chat. It's derive param BSA. So here again, we could use as well the derive param computed function, but as we have already seen it for BMI, we will show now the example of derive param BSA. So as for derive param MAP, you find again the argument by vars, which will create your new records as per this grouping, and which will populate only those variables. But we have the addition of the method argument, because several formula are available to compute the BSA. So you can have Mosteller, Dubois and Dubois, Haycock, etc. And in our example, we will use the Mosteller one. So again, we want to say that param CD is equal to BSA in our newly created records, and a value will be by square meters. You find again the argument get unit expressions, which is here also used to check the units of the input parameters. And we want both weight and weight, height and weight, to be constant and derived for all subjects. And if you look at the arguments, the height code and weight code are by default set to weight and height. So there is no need to add them here. We could delete them. It will work the same. Hopefully it works. Yeah. So we now have 41,948 observations. Still the same number of variables since we did not add any of them. And if you search for it, param CD is equal to BSA, you can see that it has well been added to our data set. So the next step is to derive our categorical timing variables, which has a protocol and analysis dependent. So here we simply do an assignment with the mutate function. So for our analysis time point numeric, we will take the time point numeric from VS. For the character one, similarly, we take the one from VS, the character time point. And for the analysis visit, we don't want, as in our spec, to populate the ones which are in screening, unscheduled, retrieval, or humble. And for all other ones visits, we will simply take the visit from VS and put in capital letters the first letter of every word. If it does not fall into this case, then it's set to NA. For the numeric version of the analysis visit, it's similar. We take our visit variable from VS, and when it's equal to baseline, we set it to 0. And in any other case, we take the character variable and keep only the numeric part of a visit. So we still have the same number of observations as in ADVS1 and the addition of our 4 variables. So again, it's added at the end. So you can see that we have our analysis time point numeric, the character one, and our corresponding visit variables, which are populated with week 2, week 4, week 6, etc., and only the numeric part in the numeric analysis visit. So sometimes you might need to derive additional records. So here it's the example of deriving new records based on aggregation records. So for this, we use the function derive underscore summary underscore records, which has a few arguments. So we want to know, to derive those records, from which data you want to create them. So our input data set here is simply the previous one, ADVS2. So we set it in data set add argument. And we will create again these new records with the grouping variables, which are defined in pharmaverse argument. And again, only the variables defined in that argument will be populated. So here we will create a record for each subject and vital sign parameters and visit and date, an average value. So we don't want to compute it on any missing values. So we can filter out the records where the analysis value is not missing. And we want to define our new analysis value to the current mean of the aval grouped by these variables. And to differentiate those records, then we can add the derivation type variable, which is equal to average. So you can see that from ADVS2, we had 41,948 observations. In ADVS3, we now have the same records plus our newly created records. So in total, we have 62,008 records. If you want to look for them, you can see that we have the type which has been added at the end of our data set. And if you want to find them, you can simply search for average, and you can see that our new parameter or new records have been added in the data set. Again, all variables which were not defined in by-vars argument are not populated. In some analysis, it's also necessary to flag the observation which are on treatment. So we can go for a little check-in again. So again, with the help of admiral discovery, let me know in the chat which admiral function could be used to derive on TRTFL variable. So is it derive var TRT-EMFL or derive var TRT-DURD function or derive var on TRTFL function? So that was an easy one. And the correct answer is, of course, derive var on TRTFL. So let's define that we want here as on treatment all observation which are between treatment start and treatment end date. So we take our analysis date that which will be used to compare. So we set it in the start date argument. And for comparison, we need the reference start date that we use for treatment start date. And our ref end date argument is set to treatment end date. So this function returns the original data frame with the colon on TRTFL added at the end of the data frame. And this function also allows you to filter out some records that you don't want to consider as on treatment. So for example, if your records for a visit are equal to baseline, have an observation date between the treatment start date and the treatment end date, here they will not be considered as on treatment because we defined it in the filter pre-time point argument. So normally you can see that we still have the same number of observations and only one variable has been added. So you can see that on treatment FL is added. And when you have your date, which is not within the time window of treatment start date and treatment end date, it's not populated. As well as the record where we say that we don't want them to be defined as on treatment. When a visit is equal to baseline, you can see that even if the analysis date is within treatment start date and treatment end date, this is not defined as on treatment. Then next part is to assign the reference range indicators. So for this, we need the function deriver IRNND. So this function requires the reference range boundaries to exist into the data set, as well as the additional boundaries analysis range 1, lower limit and upper limit. So that's why we merge them to our data at the beginning. So for this, we have defined a lookup table, which is here with our param CDs to equal to systolic blood pressure, diastolic blood pressure, pulse, and temperature. And we have here our boundaries created as well. So once it is merged, we can use our function, which will create automatically your ANRIND variable. Here I have left into comments the arguments, because by default, these are already the significant digits that we will use, and the use of the boundaries to say whether you want it, your category set to low, low or high, high, plus normal, low and high, or only to normal, low and high. So it's set to false, that we don't get the low, low and high, high values. So we still have the same number of observations, 6,200,008, and our 5 additional variables. So our boundaries have well been merged to our data set, and ANRIND has been created comparing our aval value to our boundaries. Finally, we want to derive the baseline flags. So in this step, we will use the derive base type record function. So this function requires in the argument base type a name list of expressions which will detail how the base type values should be assigned. And in the case where you have an observation falling into multiple expression, it will create you an additional record with the corresponding base type values. So it's both creating a new variable and also in some cases creating new records. In our example here with the VS data that we currently have, we don't have any example, so the number of observation will remain the same. It's important to derive the base type variable at first. For all subsequent derivation, which will use this variable, as for example, ABLFL is using it, you will flag also all your baseline records based on this variable as well. So to calculate the baseline flag, we will say that we don't want that we will flag only the last non-missing analysis value, which are prior or on the treatment start date. So to filter out that, we can use the restrict derivation function, which has a few arguments, like saying which data set is used and the function that you want to apply the restriction, and then the filter. So our values, non-missing values prior or on treatment start date is set in our filter argument. And we also use that base type is not missing, and that derivation type is missing. You know, we have created previously average records and we don't want here to flag those records. So to derive the baseline flag, we simply use the derive var extreme flag function. And we need to define its arguments. So again, we have the byvars argument where we set the grouping variables, study ID, usage ID, base type, and param CD. We say that within this grouping, we want only the last one and non-missing. So we have to order our data set by ADT, the visit, and the sequence number. And because we said the last, we set the mode argument to last. The variable that we want to create here is ABLFL. And by default, when it meets the criteria, it is set to true. So again, this argument is not really necessary as it's already the default value. So if you run it, you can see that we still have the same number of observations and the addition of two variables, which are then base type and ABLFL. Looking at our data set, you can see that base type has been added at the end. And ABLFL is populated as well as per the criteria. If you want to have a look at the records that we filtered out, okay, it might not appear, will take a long time. Yeah, it was to show you that patient having a treatment start date after the analysis date, 2012. Yes, so no, that one is populated, right? Nope. So if you compare the dates, treatment start date and your analysis date, when it's missing, it's not computed. And when it is on, it's also not populated because we flag only the records which are before the treatment start date. Since we have created our flag, we can now derive the baseline value and the baseline reference range indicator. So for this, we will use the derive var base function. So it works similarly for the two variables. We have the byvars argument, which is our grouping variables. We want to use as the source value our current eval, and the new variable that we will create is base. The filter argument is by default where ABLFL is equal to yes, but you can change it with any other condition as per your study requirements. So that's why it's not set in our derive var base call for the baseline range indicator because it's a default value, so it's not necessary to add it again. Since we have created base variable, we can now compute the change variable. So here it's a very simple call of the function where only the data set argument is needed. And because we use the change, because they are all changed, it's using ADVS 6 as default. Special note here that both pre-baseline, baseline, and post-baseline records will be populated. As per the implementation guidelines, it's left to the producer to decide how to populate or not those records. So in our example here, both baseline and post-baseline records are populated. So in ADVS 7, we now have our base variable the baseline of the normal range indicator populated as well. And our change variable is created as well and populated for all. You can see that our baseline records are also populated. So it's now time for a new check-in. So now using the reference page, so if Ben can give us the link in the chat, you can look at how to derive the percentage change on a subset of the input data set. So we want only the post-baseline records populated this time. So here you need two functions in total. So you can let me know in the chat which function you will be using.
Oh, I think this is a tough one.
Is it? At least the percentage change one. No one? I can see from Karen derive vars PCHG, and that's the correct answer. So to filter out on post-baseline records, we will use the restrict derivation function. And we will use the derive var PCHG function to derive the percentage change. So because derive var PCHG is a simple function as derive var change, in our restrict derivation function, we do not have much arguments, only the filter one saying that we want to populate only the observation which are after the treatment start date. So after our baseline records. And we will derive, and the derivation, the function used to derive that is derive var PCHG, so set in the argument derivation. So running it, you can see that our percentage change is populated. And if you scroll down, hopefully not too far, and have a look at our ADT and TRT SDT, treatment start date, you can see that when it's on the same day, for example, that our baseline records are not populated. So it did the job. So now we want the analysis flag. So the analysis flag is usually used to identify the appropriate observation to use in the analysis. This is the case when a subject has multiple observations within a particular time period. Again, with our example here, we will assume that we want the latest and highest values on treatment. So to derive those records, so these variables, sorry, it's a variable that we are adding here. We use the derive var extreme flag function. And to filter out only on treatment records, we use the restrict derivation function on top of our derive var extreme flag function. So we filter here on the visits non-missing and on our on-treatment records. And the arguments of the derive var extreme flag functions are the new var argument to say which variable we want to create. So we want to create ANL01FL. And we want to populate it using the grouping variables, the study ID, the subject ID, we want to make it by parameter and per visit, time point, and per derived type, derivation type. We said we want the latest and highest. So for latest, we said the mode equal to last. And because we want the highest, we have to order also by date and by our analysis value. By default, our analysis flag will be set to true. In ADVS 8, we should have the same number of records plus the addition of one variable. So we have ANL01FL is equal to yes. If you scroll down and look at on treatment FL when it's set to me, when on treatment FL is set to missing, our ANL01FL is also set to missing. So close to the end, we want to get the treatment information. So TRTA and TRTP must match at least one value of the character treatment variables in ADSL. Here we don't have any periods in our example, so it's a simple assignment. But if you have periods in your studies, you can visit the Admiral website and the vignette about visit and period variables. Simple assignment, simple addition of our two variables at the end of our data set. The step is to add our analysis sequence number. So since the previous one seems to be a bit tough, that one might be a bit tough as well. With the help of the reference page, can you let me know which admiral function you would use to compute the analysis sequence number? So a little hint is that it corresponds to numbering the observation within each group. So you can let me know in the chat which function you find. So as said in the chat, there are quite a few number of good answer. It's derived var ops number. So in derive var ops number function, we don't have many arguments. We have the new var argument to give the name of your new variable, which is asec. And we want to group this numbering by patient, by study and by patient. And this is ordered by patient, by study, patient, and then by param CD. By date, by your visits, time point, and derivation type. By default, the argument check type is set to none. It's easier to set it to error, that it gives you an error message when your records are not uniquely identified by vars argument and order argument. So after that, we want to define our categorization variables. So in this version of Admiral, which is 111, we currently do not have a generic function to compute and assign the avalcat1 and the its corresponding numeric values. So currently we need a lookup table and a format function, which we have created in ADaMS little helper program. So you have here the lookup table that we defined only for the height. So when the values will be, when the height will be greater than 1.40 m, we will set the numerical value to 1, and we set the corresponding character value. And when eval will be less or equal to 1.40 m, we set the numeric value to 2 and the character variable to less or equal to 140 centimeters. We said that we also need a format function. So it's taking the code as said for aval is greater or less than or equal to 140, and it will assign the numeric avalcat1. So we can use that function with a mutate function. So it will apply our function saying that it's by param cd, and we use aval as aval, and it will create our numeric variable. Since we have created our numeric variable, we can now merge our lookup table with the help of this variable and by parameter. So in our byverse argument, we set param cd and avalca1n. The data set which is merged is our avalcat lookup table that we have just seen there. So that one is set then in the data set add argument. Can already show you what it gives. In ADVS 10, we then have the exact same number of observations and the addition of our variables compared to ADVS 9. If you scroll to the right, so it's not filtered, if you go to see the last variables, you can see that we have ASEC, which has been created, avalca1n and avalcat1. And because it's computed only for height parameters, you need to filter to see the right results, which was height. And you can see that it's populated as per our defined lookup table and format function. Finally, since we have derived all our records, parameters and variables, we will assign param and param-n variables. So there are two ways to do it, either with the derived merge function and the lookup table that we have created at the very beginning of this data set. So that one. Or as shown by Ben in ADSL, we can also use the create var from code list function, which is using your code list from the specs. So then it's looking very small too here. So we have our code list defined in the specs. And we will derive at first param. So the variable that we want to create goes into the out var argument. So we set param. And it's created from the param cd, which goes into our input var argument. By default, decode to code is set to true. Here we have to set it to false, because if you look, our input variable is param cd. So this is our code, and our decode is param. So it's the reverse of what does the function by default. With the set decode to code is equal to false. Similarly, we create param-n with the help of param cd. So we have in the out var argument param-n and in the input var param cd. We don't need to set decode to code to true because it's the default value. And if you look at the specs, we have our decode to our code, which will be created. So that's true. So looking at our data, final data set, we have our param CDs, we have our parameters, and paramen created, as well as still our previous variables created there. So since we are done now with ADVS, we can merge all our ADSL variables that we did not merge at the beginning. So we're using the reverse merge function, and we merge them by study and by subject identifier. And we want to check that all our variables that we have created within all these steps are well defined in the specs, and that we don't have any additional variables. So we can use the metatool package for this to check our data set against the specs. So as displayed by, as shown by Ben, we can drop the variables. We can check that no other variables have been added and which are not in the specs. And we will order our columns as per spec and sort our records as per the key variables defined in the specs. So we had in ADVS final data set, 62,008 records and 100 variables. And in our ADVS data set, after these checks, there are only 68 remaining variables. So it has dropped all these variables which were from ADSL and which were not defined in our specs for ADVS. So if you look at ADVS for now, you can see that all the created variables in our intermediate steps do not have any labels. So with the help of the xportr package, we will assign the type, the length, the labels, and the formats of these variables as defined in the specs. And also we will add the label of our data set and finally write it as an XPT file. So if you go back to ADVS dataset, you can see now that all our variables have the label applied. And if you go to dataset folder, our XPT file has well been created. Yeah. I think that's it for me. Thank you.
Thanks, Fanny. So that's a tough data set to present. I definitely got the easy one, but I really appreciate you doing that, Fanny, walking through those functions. I think Admiral makes ADaMS programming really fun and exciting. So I think what we want to do next is for me to share screen and kind of go over some of the resources available and some other bits and bobs. So let's see here. Let me share screen. And this is and can I just get a quick confirmation? Fanny, are you able to see? Or anyone?
Yes, can see your screen.
Okay.
At the first slide.
Okay. and then we'll go down to, well, before I go into resources, just so you guys know, we did scrape all the information on the R version and the packages that we used, which you can find at the end of the slide deck. So if you're curious about which version of Admiral, metacore, metatools, even dplyr, you can see here at the end of the slide deck what we used. I used Windows to work on my code, but I believe Fanny used Posit Cloud, which is a Linux system to work on stuff. So I think it's a kind of good show that you can work on either operating system to make use of this. So let's see here. So just some stuff on closing resources, or some closing thoughts on resources that folks can use. So Admiral Discovery, I think, as shown in the throughout the workshop, is great for quickly finding typical variables that we make for ADaMS with points to where typical functions you might use, and even links out to the templates. It's not holistic, but I think it does cover quite a lot of information to help you get started. One thing is that on the Admiral website, we tend to keep things very scoped to just doing ADaM derivation, so we don't have a lot of use of metadata like we did in the workshop. Actually, it was a question that came up, is that they noticed the templates in Admiral didn't contain any metadata, and it's just, again, we kind of keep it scoped just to doing ADaM derivations. But if you're curious about seeing more examples, you can come to this pharmaverse examples site, and you can actually see different data sets being used with the other packages to make, for example, this is an ADRS data set, and there's an ADTTE and some PopPK and PC and ADSL. So you can see all these specs being used and other resources being used to make these ADaMS. Also, if you're curious too, there's stuff on TLGs, interactive TL applications, and down to the nitty gritty, even doing some logging in R, which is important for the work that we do with keeping things traceable in our work. So just to make you aware of those kind of resources. And then where did my slides go? Lost my slides. Sorry about that. 1 second. So that was Admiral Discovery, pharmaverse examples. Again, I think our ecosystem is very exciting and powerful, and there's a lot of infrastructure built through the tidyverse and RStudio and Posit that we've leveraged in the pharmaverse. So we have dedicated websites to each of these packages, just like dplyr, lubridate, stringer, all these other great packages that you hopefully make use of. We have our own package down sites, Admiral, you saw throughout the presentation, but also metatools also has its own dedicated website. And I think this is pretty standard within the pharmaverse and our ecosystem, is these websites are available that give you documentation, give you examples, and give you the ability to find help on the packages. And let's see. And I did want to give a shout out to, so we sort of, Admiral is very scoped to creating kind of generic ADaM data sets, but you might, if you're in a certain disease area, have unique ADaMS that are very specific to your disease area. And so there are other Admiral extension packages that have a few functions available in them, but really showcase how to do specific ADaMS for those disease areas. So we have ophthalmology, oncology, pediatrics. There is an Admiral vaccines, an Admiral metabolic that I think is in the works, and an Admiral pediatrics, which I believe, Fanny, you worked on quite a bit. So those are all available for folks to look into. And I just want to say, with Admiral, let me go to the, if you're exploring Admiral and you find something lacking, if you have an idea or have a question, we really encourage you to come and make an issue. It can just be on documentation, like you think an example could be made. There was a good one in the chat about screening a bit for baseline data, and maybe we could make an example of that. But you could, come in and make an issue around documentation. If you think a function could be created to address a specific issue, you can come in here and make the issue for the function. Or if you think something is a buggy or not working, come in and make an issue. I think don't worry, the developers and Admiral, we have thick skin, so we don't take it as criticism. We want to enhance the package and make it as best as we can. And the biggest thing too, if you're very interested, I'm not a software developer, but I found participating in open source packages has been very fulfilling, and being able to give back to the packages I use through making the code updates myself is powerful. More about open source development, but also to get familiar with a lot of these interesting tools that are available on GitHub. So definitely, if you see an update that you want to see made, put it forward. But if you also want to make the update, I think within Admiral, we definitely encourage that kind of participation. But it's not a requirement. So if you make an issue, don't feel like you have to work on it. But if you want to work on it, I think it can be a very rewarding experience. So just some closing thoughts. We only showed you a few of the pharmaverse packages and functions today. Definitely encourage you to explore deeper. We do have, if you want to, like I said, contribute either ideas or new packages, jump in, make issues on the different repos within pharmaverse. And then be sure to join the Slack channel. It's not a heavily used channel, but it is, when people have questions, and I'll put it in the chat. To change it to everyone. But if you got questions or concerns or just how to get started, there is a community on there that's very supportive, that you can ask questions and get you started. And there's different sub channels for different packages that I encourage you to check out. And then I think that is my last slide. Yeah, so that takes us back to where we started, where we were waiting for the Zoom meeting to start. Yeah, we can take questions. I gotta warn you, I'm a little tired, so I might not have the best answers. But if people have questions or concerns, we can come off mute and discuss. I don't know if I can always answer, especially coding questions off the top of my head. But if you have questions, now is the time. You can post it in chat too. You don't have to come off mute. You can post in chat, and we can talk about other stuff. Yeah,
Hi, Ben. I have a
Hey,
question. Like how to open the slides on our end. Like do I need to download the whole folder of slides and then render it?
so you want to run the QMD file?
Yeah, the whole presentation, the
Yeah.
slide. Yeah, the
So
QMD.
yeah. So if you so I'm sharing my screen. You need to download Corto. So if you have RStudio, access to
Yes.
RStudio, you just need to download the packages that are associated with Corto. So I think that's like R Markdown and a few other bits, and then you just hit render.
Oh. So I just need to download this file, the QMD. I don't need to download the whole folder, right?
That's correct. Yeah, you just need this
Oh,
file.
okay. Thank you.
Yeah, they make it super simple.
Yeah.
Yeah, it looks like the recording is going to be in a couple months.
Yep, and we'll keep the Posit Clouds up. So if people want to continue to use that and explore, feel free to use that within the R and Pharma organization and Posit Cloud, and you should be able to play with all the examples or add new examples or do whatever you'd like to do in that session.
Yeah, and if you find any pesky bugs or come up with any ideas, don't hesitate to post on our GitHub issues or in our Slack channel. I think interaction is always good. I mean, definitely, I was in a hackathon workshop where it talked about kind of conventions about posting things on the on people's GitHub repos. Is, do be kind. We are human, and we do we have spent time on this package and packages. So just we do accept criticism, but just be kind when you're being critical. I think that goes a long way for uh, just for getting updates made.
You can't post it in all caps.
Yeah.